Hey Precalc students, welcome to today's lesson on solving trig equations with affected domains. So one of the recommendations that I always tell you guys is to make sure that you are putting your special right triangles at the top of your paper. So if you don't have these memorized, you need to make sure you do that every single time, okay? When you're given any kind of notes, homework, test quizzes. Also remember the signage for each quadrant. Cosine is the x and sine is the y, right? So cosine comma y, cosine comma sine is x and y. And that tangent, that's also important too to remember, tangent is y over x. Okay, so the main part of this lesson, guys, is that sometimes within the problems, we're going to have an angle that is either being added, subtracted, multiplied, or divided by a number, and that directly affects the domain. Okay, so notice that in example 1, they're asking us to solve the equation over the domain of 0 to 2 pi. 0 included, 2 pi not included. That's the normal domain that you've been given for number 1. However, if you look at the problem closely, okay, the angle inside is being added with pi over 6. So what that means is that you're going to have to adjust your domain accordingly. So you're going to have to add pi over 6 to the domain. Okay, so instead of a domain, so I'm going to write down old domain of 0 to 2 pi. I'm going to leave some space here. I need to make adjustments by adding pi over 6 to both parts of the domain. So our new domain for this problem is going to be pi over 6 and then 13 pi over 6, because 12 pi over 6 represents 2 pi. Okay, so just keep that in mind. That's going to come into play in a little bit. Okay, that when you're dealing with this problem, there is going to come a point where we have to address the fact that we have a new domain. All right, so step 1 though, you don't have to worry about that new domain yet. You're just going to focus on the main question, right? Which is tangent of what angle is 0 equals 0. So you're going to, choose whatever option is appropriate. So you're going to ask yourself, is the tangent of pi over 3 going to give me 0? What about pi over 6? What about pi over 4? You're going to go through all your special triangles. And if none of those work, then you're going to ask yourself, okay, which quadrantal angle could it be? Since you want tangent, which is y over x, to be 0, then it has to be this one or this one. Now, when you're answering this step 1, okay, this first part of the question, you're dealing with just the regular domain. So we're not, notice we didn't have, this equation had nothing to do with x plus pi over 6. Okay, we're kind of ignoring that for now. So right now, between 0 and 2 pi, the answer of what angle has a tangent of 0, the answers are 0 and pi, which are this one and this one. Okay? So the first part of the problem is to just ignore what's happening with the angle, like it could be added, subtracted, multiplied, or divided. You're just focusing on the outer parts, right? So what function is it and what does it need to equal? In step 2, that's when we bring back the x plus pi over 6. So what you're going to do is you're going to set an equation of x plus pi over 6 equal to each of the answers you got from part 1. So one of the answers we got for part 1 was 0. The second one was pi. So you're going to set your angle of x plus pi over 6 equal to that. Okay, so again, our answers for the first part, which was tangent of what angle is 0, were 0 and pi. Now you're going to set your angle, which was x plus pi over 6, equal to both of those answers and solve for x. Notice this is addition, so you're going to subtract pi over 6 from both sides in both of these. You're trying to solve for x, or you're using inverse operations. So x equals negative pi over 6. And then here you want to convert 1 pi into 6 pi over 6 so that it has a common denominator, right? So that you can do 6 pi over 6 minus 1 pi over 6, which gives you 5 pi over 6. The way you finish this problem is as so. Using your new domain, okay? So in step 2, using your new domain of pi over 6 to 13 pi over 6, you're going to figure out what angles match up with the answers we got. So notice one of the answers we got was negative pi over 6 and 5 pi over 6. So I'm going to go ahead and graph those. Okay, so negative pi over 6 would be over here. So I'm going to write myself a little note, right? If this is 0, you go down. That would be negative pi over 6. And I'm also going to graph 5 pi over 6. So 1 pi over 6, 2 pi over 6, etc., etc. 5 pi over 6 would be right here. Now, as I look at my new domain says that I can only give answers between 1 pi over 6 and 13 pi over 6. So automatically, negative pi over 6 cannot be an answer. However, I can give its coterminal angle as an answer as long as it fits within the domain. So remember, your domain says you can go from pi over 6 all the way to 13 pi over 6. Okay? All right, so if you notice, 5 pi over 6 is within that rotation. So your final answer is going to include 5 pi over 6. It cannot include negative pi over 6 because that answer is negative and the domain doesn't have any negatives. But look at where negative pi over 6 lands. It's in quadrant 4. So if you keep counting from 5 pi over 6, 6 pi over 6, 7 pi over 6, etc., 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 you can get to 11 pi over 6, and that one is coterminal, meaning it lands in the same spot as negative pi over 6. So even though we couldn't give negative pi over 6 as an answer, we can give 11 pi over 6 because that is within the domain, right? That's smaller than 13 pi over 6. So those are your final answers. Remember, you are more than welcome to pause, rewind the video at any time if you need extra help. So let me zoom out a little bit and just remind you what the steps are. Notice that whenever there's something added, subtracted, or multiplied with your angle, right? So look at the original problem. If there's anything added, subtracted, multiplied, or divided with your angle, you are going to have to adjust your domain. And that's going to happen in step 2. In step 1, you just focus on the outer values. Tangent of what angle is 0 in this case. Find your 2 answers. And then you're going to set your angle equal to those. Okay? So our angle in here was x plus pi over 6. So you're going to set that equal to 0 and that equal to pi. And then solve it, but make sure that you adjust your domain and pick answers only within that domain. Make sure you're doing this without a calculator as well. Okay, so if you look at the original problem, it says secant of an angle divided by 2. If your angle has any number added, subtracted, or multiplied to it, that means you're going to have to adjust the domain. So you're going to need to divide the domain by 2. Okay, so you can do that now or you can do it later. It's up to you. Last time I did it first, but I can show you that it really doesn't come into play until step 2. So in step 1, you're trying to find secant of what angle is positive root 2. So if you look at your options, it's either going to be pi over 3, pi over 6, or pi over 4. If you use pi over 4, you will get hypotenuse over adjacent to be root 2 over 1. Secant is related to cosine. So wherever cosine is positive, that's where your secant is going to be positive. Okay, so remember we're going to use pi over 4 as our reference angle. Where is cosine positive? In which quadrants is cosine going to be positive in? The correct answer is quadrant 1. Cosine is going to be positive, so we need that angle. And cosine is positive in quadrant 4. So we need this angle. Okay, so counting by fourths, work your way around the circle and find both of those answers. Pause the video and push play when you're ready. Okay, your answer should be pi over 4 and 7 pi over 4. So now in step 2, you're going to set the original angle, which was x divided by 2. You're going to set up two equations where you have that angle and its divisor. What is it? You're dividing it by 2. Right? That's what it appeared like in the original problem. You're going to set it equal to your two answers from the previous problem. Okay? So for the previous step, which was pi over 4 and 7 pi over 4. Okay, so one for each one. Okay, then you're going to solve for x. So in this case, you're going to multiply by 2 on both sides. Here you're going to get 2 pi over 4, which reduces to pi over 2. Over here, you're going to get 14 pi over 4, which reduces to 7 pi over 2. You could also reduce along the way, guys. So like 2 goes into 4 twice, right? So you could do that to get your answers. But we can't really say that we're done yet because we now need to ask ourselves, are these within the new domain? So for that, we need to know what our new domain is. The old domain was 0 to 2 pi, right? But now we need to change it so that our new domain reflects the fact that we, look at the original problem, it was x divided by 2. So our domain needs to be divided by 2. So our new domain is going to be 0 to pi. Are the answers that we got of pi over 2 and 7 pi over 2 within that domain? Let's see. Pi over 2 is over here. And 7 pi over 2, you'd have to go around the circle more than once. So pi over 2, 2 pi over 2, 3 pi over 2, etc., etc. So 7 pi over 2 would land over here. But we only want an answer between 0 and pi. Okay, so that means that's only half of a circle rotation. So that means that only pi over 2 is a solution. Not 3 pi over 2, not 7 pi over 2, even though they're coterminal, right? 7 pi over 2 is definitely way too big to be within 0 and 1 pi, which is half of a circle, right? 180. So 7 pi over 2 is too big. Even 3 pi over 2 is too big. So the coterminal angles are too big to fit into the new domain. All right, guys, as always, please make sure that you reach out if you need extra help, and I hope you guys have a good day. See you soon.